In this section, we'll see how we can improve developer productivity through automating a build, unit testing, and code quality to provide immediate feedback to the team about the latest code changes committed to the version control. We'll learn how to set up a continuous integration build in Visual Studio Team Services that helps the code stay robust enough that team members can fearlessly make changes to the code base without worrying about breaking existing functionality. Unit testing has been around for a while and is generally considered a best practice for modern development. We'll see how using CI builds we can automatically trigger unit tests that help us increase the overall quality of software and reduce the number of bugs that are created. We'll see how using code analysis and code metrics rule we can provide developers better insight into the code they are developing. Developers can now understand which types or methods should be reworked or more thoroughly tested based on the feedback from these rules. Development teams can identify potential risk, understand the current state of the project, and track progress during software development. Finally, we create a CI build for our Wonders API in Visual Studio Team Services and configure the build to perform activities like automatic build, code analysis, unit testing, and publishing the Docker images to the Azure Container Registry for deployment. Delivering quick and frequent releases for a large complex system with multiple components becomes cumbersome and time-consuming if done manually. That's why many teams opt for build and deployment automation to ensure faster releases and reduce manual intervention. Automating the build process ensures that on every commit, a series of automated steps are carried out to perform tasks like compilation, unit testing, tagging, versioning, code analysis, etc. This video will have a look into build automation in Visual Studio Team Services and how it helps in continuous delivery. Continuous integration emerged as a best practice for software developers to integrate their code changes with the rest of the team's code base. CI requires the development team's code to merge to a shared version control continuously to avoid the problems of merge conflicts, hard to find bugs, diverging code strategies, and duplicating efforts. Continuous integration encourages developers to share their code and unit tests by merging their changes into a shared version control repository after every small task completion. Every commit to the master repository will trigger an automated build that grabs the latest code from the repository, which will build, test, and validate the full master branch. Continuous integration helps teams to keep the master branch clean. Teams can leverage modern version control systems such as Git to create short-lived branches to isolate their work. A developer submits a pull request when the feature is complete, and on approval of the pull request, the changes get merged into the master branch. With continuous integration setup, bugs are caught earlier in the development cycle, which makes them less expensive to fix. Automated tests run for every build to ensure that builds maintain a consistent quality. Continuous integration ensures that everyone can easily see the state of the system and the changes they have made to it. If the build fails for some reason, the developer who was responsible for breaking the build will be notified immediately, and it should be the top priority to fix the build. A continuous integration build performs these functions. It pulls down the latest source code, resolves the dependencies, compiles all the projects, performs code analysis and code matrix checks, runs all the unit tests, creates an artifact that can be used for deploying the application using an automated release pipeline, and notifies the development team about any failure. Let's go into Visual Studio Team Services and see how we can create and configure continuous integration builds for our Wonders API. This is Visual Studio Team Services, and I'm into a team project that I've configured for the Wonders API. If you look into the code, we have the Wonders API source code over here. I have the files for the Wonders API. And if I go to the builds part of Visual Studio Team Services, I don't have any builds configured right now. So I'm going to create a new build. So to create a new build, you can click on new definition, and then you can choose what's the source of your repository. So in this case, we are using Git. So I'm choosing Git. And if there are multiple repositories, then you can see from the drop down that you have multiple repositories over here. In our case, we have only one repository configured. So I just choose the one which is defaultly available, and the default branch that will be used for scheduling the builds. So if any changes goes to the master branch, we can kick off a continuous integration build by choosing the branch over here. So if you click on continue, then the next process is to choose a template. A template is basically a series of steps that will be performed when a build kicks off. So there are already some pre-built templates over here. You can see that based on the type of application, you can choose one of these if you're using one of these projects types. Otherwise, you can start with an empty process and add the custom steps whichever you want. But in our case, we are creating an ASP.NET Core web application. So I'm gonna just select this one. So it will prevent us from doing all those tasks manually. So I'm just gonna click on apply. And then you can see that I have a series of pre-built steps over here, like restoring, build, testing, publishing, and kind of things like that. If you don't want to do one of those tasks, you can just disable it or delete it. So if you just select this one, you can right click and say disable task or remove select task. We're not going to test as part of this section. So we will enable this test part when we look into unit testing from Visual Studio Team Services. But for the time being, I'm just gonna disable the test part. And you can see that what kind of triggers you want, for example. So this one doesn't have a trigger because we are creating a continuous integration build. I'm just gonna click on enable continuous integration and then which branches I need to look for code changes. So if I want feature branches and all those things to look for code changes, they're gonna add over here. But we're just going to look into the master branch. So I'm just choosing master branch. And then let's go back to the task one more. In the restore, what it does is it will run the .NET restore command and restore all the NuGet dependencies for the project. This will build our project and this is going to publish our project. But I want to publish the ASP.NET Web API project. So I'm gonna change the path for the working directory. I don't want the test projects and all those things. So I just click on the web API and say, okay, so that's the project that is going to use for publishing it. And the last one is to publish the artifacts that is part of the build. That's it. We have created our continuous integration build. So let's save and queue a build and see what happens. When you save and queue the build, Visual Studio will choose an agent, or you can choose an agent to where the build should run. There are multiple types of agents. You can have on-premise agents and you can also use the hosted agent that is part of the Visual Studio Team Services free edition. I'm going to choose the hosted one and then you save and queue. And now build is queued and it will wait for the agent availability. And once the agent is available, then the build will start and you can see the steps over here. So now the build has been started and then you can see the steps that are getting executed. It takes some time and let's come back after the build is finished and then we'll have a look into the output of the build. The build is finished and you can see that the steps are executed as we have seen in our build template. So the get sources was completed, restoring a build, publish and publish artifact was completed, and we have the build completed in 2.3 minutes. But this was the manual queue which we have done. What we want to have a look is how continuous integration works. So let's go back and make some changes to our project and commit it to the master branch and see whether that kicks off a build and continue this process. So I'm going to go back to my code which I've created for this application, and I do have some controllers over here and a value controller which I don't think is of any use because we are using a Windows controller to get the old Windows. What I'm going to do is I'm going to delete this values controller and then commit it to the master repository and see whether that kicks off the new continuous integration build. So I'm going to delete the values controller. So delete it and I'm going to commit the changes now. Removed values controller. I'm going to commit it and I'm going to push these changes so that it's going to the master repository. Now, if I go back to my Visual Studio Team Services, you can see that immediately it kicked off a new build. So that's the second build which is kicked off as part of the continuous integration process. And it will follow the same steps as we are configured. So it's going to wait for the agent and then perform the same steps of build, test, and publishing it. So that's how continuous integration works in Visual Studio Team Services.